Hey there, YouTubers, friends. It's been over a week, maybe, give or take. I've got this Sharks shirt on. Now, with me, it's not like I'm vested in any sinister connotation of shark. I really just like scuba diving in the open ocean and sharing it with other species. So, like, sharks are not. I got educated by a very good scuba diving teacher who did not preach fear, and he was very appreciative of wildlife and sharks and stuff. So, anyway, I have this shirt. It reminds me of the beautiful outdoors and so on. And indoor world, we're all indoor cats these days, a lot. If you look back in the timeline, you'll see. And I was teaching statistics, you could call it, but more just the Python stack of tools that relate to what today we call data science, right? And I was teaching teenagers, and then I shifted back to andragogy adults. Not that teens aren't adults in a lot of ways, so it's good to have a full spectrum. Last night I got a little bit wires crossed with some students, and I was trying to show the dot sort method, and it's working great over here, but I'm in a numpy array, right? Dot sort works fine for those. I'm generating random stuff. Now this, by the way, is the old way of getting random integers, what I'm highlighting. And a big theme for me lately has been studying random number generators and the whole history there. Like if we go look at my viewer history, which I often do, everything you see me doing is sort of the flavor of my channel in general. And what I do in this channel is I push a lot of mainstream stuff that nobody has any beef with. It's clearly mainstream stuff. But then I pepper it or spice it up with a little bit of oddball physics, not even physics, more like the Bucky stuff, I call it, right? And it has to do with, you could say topology, and what's simpler, a cube or a tetrahedron? Just thinking topology, right? So here is a very interesting talk by, I believe, the chief promulgator or inventor of this PCG family, which is superseding the Mersenne twister. And so let's see where she's talking. I just listened to this last night and again this morning because I fell asleep listening to it. Not because it was boring, because I was wiped out and I was looking forward to waking up and coming back to it. Right? She's a very good speaker. She thinks really fast, and this was a very fun presentation. So I curate these things when I find something that really I think has good qualities, belongs in my collection. I actually embed it somewhere in my, like in this case, machine learning Jupyter Notebook. I'm talking about racing the different machine learning algorithms against each other, which is often done. Is a random forest better than a support vector machine in this case? Let's just check it out. Let's just race them and see which one does better. Maybe we'll work on consensus among several, right? Ensemble approach and so on. So this guy is he in New Mexico? I loved his random number talk. It was beautiful. But he was pushing, let's see if I can find that. He was pushing the Mersenne, which in his time he's making that video, the Mersenne twister, is probably the best out there, right? So he's saying make sure that's what you want. But now we're in 2020, and a big thing that's happening here in 2020 is numpy, which is at the basis of a lot of what goes on in the pandas stack. Numpy, I don't know what I'm searching on here exactly. I think I was searching last night on languages that target the JVM, right? Because I'm trying to get my students up to speed in many dimensions, right? What is a VM in that sense, right? Virtual machine. So numpy is deprecating what they used to use for their random number generator, which was called random, what was it called? Random state, maybe? And then now they have something called generator. Let's see if I got that right. Let's see if this takes me to a page that it looks familiar. Okay, yeah, random state. I guess I did get that. But they're changing over from the old to the new, right? Random number generator policy. That sounds official. Something with the word policy comes from the old Greek word for city, polis, and so also the word police there, right? So, okay, this is some kind of policy about backward compatibility. But random state was at the core of how they used to generate random numbers, pseudo-random numbers in numpy, and now they've decided to switch over to this new random number generator. That's the class that this. Anyway, you get the flavor, right? What we're talking about here. So to me, let me summarize where I'm going with statistics as a subject. A lot of it is about, the inductive aspects of just even pure math, right? Like Polya points out, as Euclid pointed out, Polya points to Euclid pointing out, not Euclid, Euler. Polya of how to solve it points back to, and other volumes, points back to Euler talking about how so much in mathematics is inductive, even in pure mathematics. Like I'm trying to verify one of these Ramanujan things. The best I can do is get an arbitrary precision number going and verify that the left and the right side of the equal sign continue to get more and more convergent, right? We do have convergence going. Even one digit off and it's done, right? If this is supposed to converge to pi, if it's got to keep getting closer, right? Once it gets a little further away, there's no going back unless it's an oscillating approach, and those do exist. So I'm thinking that we need statistics inside of purely deductive worlds, and this corresponds to also the chaos thing. Totally deterministic, but totally unpredictable. Totally deterministic in what sense in that case? How do we mean deterministic? Well, it's the idea that if you have the same seed, and it's the seed we don't see, that you can then continue the series exactly. You just have to put in the right seed. You basically have to set the random number generator back in time and set it running forward again. And it will give exactly the same results. That's what the meaning of pseudo-random, right? So that's a kind of a controlled chaos that we can induce using software. And we need those in our computer programs. We need sources of entropy, as they're called. And can we do it in such a way that we can reproduce it? That has advantages. So real entropy, pure entropy that you could never rewind the clock, is maybe less useful. Then we could have that same randomness we had before. Control that randomness. Very paradoxical and interesting. So that's kind of the mainstream stuff that a lot of people think about, and then I'll toss in links then to like synergetics, where Fuller meditates on, how these probability curves might map to the surface of a sphere instead. Like, we want to show more of our 2D thinking in a 3D form, as we would conventionally say. We might go to spheres in that case. So just thinking out loud, as usual, and thanks for listening. Back to teaching Python and statistics.